My fast back any problem sets I got yesterday, if I didn't get it from you, I went ahead and just so that, because our grading cycle ends on Friday, so that you can kind of see where your grade is at, I put in, so that it's not a blank and it then it doesn't affect your average, I went ahead and put in a 5 for people I didn't get it from, even though, know that if you get it to me today, tomorrow it's not going to be a 5, but I wanted you to see, what will happen if you don't turn it in by the end of the week, okay? So if you take a look at your average, that should be the latest I've got for you, assuming, if it were to end today, the grading cycle, okay? I also have some people's old stuff that I'm passing back that I just want to read. So let's take a look at these and kind of see how we feel, knowing that tomorrow is our quiz, and so our quizzes and tests definitely do have challenging problems, so I tried to make today's do first, definitely some rigorous problems, but things that we've seen before, but maybe in slightly new way for us to kind of see how we feel. So again, if you were a person that going through this, you were looking through old notes, but you were really weren't able to get started on these, this is low stakes right now because it's not the quiz, it's the do first. So that's okay, but I need your brain to be then actively engaged as we go through this. Don't just be writing the letters and numbers I'm writing, because that's not going to help you tomorrow. You might as well not write it if you're not soaking it up as we go, okay? So turn those brains on. Let's take a look at number 2, see what we come up with. So the goal is to get these in order, which means you're kind of thinking that you need the value for each one, right? If I would have given you log, let's start with an easier one, log base 2 of 8, which we've seen a lot. Raise your hand if you can tell me what the value of this would have been if I would have given you this one. And this should have a lot of hands. We should feel comfortable with this, because you're thinking 2 to what power is 8, Brian? 3. Okay. So the goal would be oh, let me get a number for each of these and then put them in order, right? Okay. However, when we get to this first one, let's translate it. We still want to write things down. We shouldn't be able to just put them in order without writing. Can someone translate what you're thinking in your brain for this one, Danthea?
5 to what power is 55?
Okay, and this is where we might have been stuck, because it might be tempting. 5 times 11 is 55, but that's not going to be your power, right? And when we think of powers, 5 squared is what?
25.
And then if I go to 5 cubed, I'm all the way at bigger. 25 times 5 again would be 125. So it's way bigger than this already. Okay, so I don't know the value. The value is going to be a decimal, but I know it's going to be between, raise your hand, between what and what, based on what we just talked about, please? 2 and 3. It's going to be like 2 point something. That should be enough information if you keep going to put these in order, because we should be able to like eliminate and figure out like, oh, this is between 2 and 3, this one's smaller than 2, this one, so on and so on, okay? So let's keep moving. Let's talk about the next one. So we know this one's between 2 and 3. You're thinking that in your head. You're moving on. The next one, let's simplify a little bit before we get to this step. The square root of 100, Giselle, is what? 10. So if I think of this as log base 5 of 10, then same thing as Dianthea did. I'm thinking 5 to what power is 10 for this one. And if I, again, I'm like, oh, darn, I don't know that one. Don't give up. Because we know that's going to be bigger or smaller than 2, just from looking. It's got to be smaller. So already I know that this one is smaller than the other one, right? Okay, cool. Let's go on to the last one. We got to put all 3 of them in order. The cube root of 75 is not as friendly like as for me to do the square root of 100. But we did learn that I can always take roots and rewrite them in a creative way. Brian, you remember? Cool, I can rewrite that. I'm going to pretend like that root's not there. And I can think about it instead of as a cube root, as a third power. And the reason I like doing that is because yesterday we learned this thing called the power property, which means someone who was here from yesterday who can tell us where our powers, and people that weren't here yesterday, this is what I'm going to catch you up on. A power could also be written where, Christina? At the front. So this is the same thing as 1/3 times 3 log 5 of 75. So the 1/3 on the 75 can come out front. And that's helpful because now I can just multiply 1/3 and 3. And that's 1. So I end up with 1 log 5 of 75, or log 5 of 75 is the same thing.
Go back.
Yep.
What did you do?
The 1/3 from up here, we used the power property and took it off of the 75 as a power and put it in front of the whole thing. And then 1/3 times 3, since these are 2 numbers being multiplied, we just multiplied them. If I have 3/3, a third, that's 1 whole. So I just have 1 log 5 of 75 or log 5 of 75. Okay, the 3 and the third cancel each other out. Okay? Okay, so now I'm thinking 5 to what power is 75, okay? Thinking about that again, oh no, it's between 2 and 3. But let's think, because this was also between 2 and 3, which one is going to be slightly smaller, even though they're between 2 and 3? Jamie, you got an idea?
Log base 5 or 55?
Yeah, this guy, right? Will have to be closer to 2 than the other one, right? Okay, so we end up with, dun 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 dun, final order. The smallest of all of them was this one, right? Smaller than 2.
Yeah.
5 is something smaller than 2 is 10. So log base 5 of root 100, that's the original version of it, right? The next one, if we're looking at these two, Jamie said this one's got to be slightly smaller to get it 55 versus 75. So log base 5 of 55. And then finally, 3 log base 5 of the cube root of 75. Okay, so that's an example of what I would consider definitely a rigorous problem with evaluating logs, because you couldn't completely evaluate it, but because they asked you to put it in order, not just for like the answer of the logs, you have enough info to do that. Okay? Do we feel better about that one? Okay. Number 3. Happy Halloween, by the way. Huh? Anyone going trick-or-treating? Huh? I am super excited because this is the first time we've lived in our neighborhood we live in now, because I moved in right before the school year started. So I have a little trick-or-treaters coming around. I am. So I bought, apparently our street is like super popular. They like block off the street and there's kids everywhere. So I bought like 3 mega bags of candy. So if not many people come, I got a lot of games.
Good go.
I'll take it.
I didn't want to run out.
Where do you live at?
Where do you live?
Huh? Where you live?
Elmgate.
Oh, never mind.
No, it's my street's called Elmgate. It's in
It's
Spring
when
Creek.
you know where we're going. Oh, wait, you're not going. You're doing your school.
I live actually really close to Northbrook, so I don't know why I teach here. But I didn't. Instead, I drive all the way down here. Okay, so let's take a look at the second one. Number 2. In the last class it was fun because Omar was in there, and so we were like hoping that Omar was right. So let's see. Anyone taking a look at this? We could expand it ourselves, but we got 2 answer choices to look at. They could both be wrong. Okay, they could both be wrong, but I want you to think back to what we did yesterday, which meant that we could take things being multiplied, we could split it to addition, we could take things being divided, split it to subtraction, we can take powers, we already saw that, and they can go in front. Okay, so if you look at this right here, looking at Omar and Nate's work, one of them, they could both be wrong, but one of them from the beginning we should probably be able to eliminate just by looking without even starting to break up our log.
Oh.
Looking at them, which one cannot be our right answer from the get-go? Kevin, you got an idea?
I said Nate because the exponent, his exponent has to be in front of the log.
Okay, so he knows this 4 exponent right here should be in front, and he's got like a 2 in front of all of his. He somehow moved like this base in front. Do we have a rule that says you can do that?
No.
No. So in general, all of his bases are now 4. Should our base in any of these rules ever change? Right, like this B is still with all of the logs, so I should still have for sure log base 2 on all of my logs.
Yep.
So his is definitely not right. Omar's looks better because we got 4s in front, and Kevin just shared that our exponent of 4 up here, we could move to the front of our log. He also has a base of 2 on all of his logs, so that looks good. We just need to check and make sure all the rest of the details are good, and then we can say Omar's correct, or if not, then they're both going to have a mistake. So any other thoughts to share about whether they think the rest of Omar's details are good, or whether there's something else going on? What do y'all think before I tell you the answer? Anthony's maybe sure, but I've already heard from her. Anyone else? Be brave. It's Halloween. There's scary things going on today. Be brave. Let's practice our pre-cal bravery first. I already heard from Kevin too. Kevin Dandia, you're wonderful. I'm proud of you. Giselle, thank you.
Oh. What was that?
What do you think about Omar?
Well, I have a question.
Okay, I'll just take that instead.
The 4,
Mhm.
does it also go to the denominator? That was what I
So in general, when you have something like this, let's just look at this like by itself. Okay? When we have something like this, when I have a power over something like this, have to distribute that power to everything.
Oh.
So this is the same as x to the 4th, y to the 4th, and z to the 4th.
Okay, so
Which, it makes sense because he has a 4 in front of all of his, so that makes us feel better,
he's
okay?
agree.
Messiah?
Well, I'm sort of on both because it's dividing both x and y by z, but they're x and y multiplied, so.
Cool, okay.
Yeah.
So let's think order of operations. If I were to go backwards from his answer and try to get here, the first thing that I would do is I'd put these 2 together because you're going from left to right with adding and subtracting. And so we'd put those together and we'd have x times y, right? So we'd have, x times y. And then the subtraction being then we would take that and divide it by the z. And we would get that. So this is the multiplication. The addition of x and y means they're going to be multiplied. And then subtraction came from what? Division, which means we should be dividing by this c. So Omar is correct.
Correcto.
He's good to go. Correcto. Good job, Omar. Yay, Omar. Okay, cool. Moving on. I already mentioned that for problem sets that you gave me yesterday, you either got it back so you can use it to study for tomorrow, Or if you did not give it to me, make sure I get it today. But what I did in the grade book, I mentioned this, is I went ahead and put in a 5, pretending as if I'm never going to get it from you, which isn't going to happen. But we're just going to pretend so that people can see where their average is at as we come to a close for A2. So get that in so that I can change those 5s to something higher. That would be lovely. And then participation points, I got my stamp in hand because I want to make sure we get as many of those for the last thing that you get to turn in by the end of the week, okay? Okay, your quiz tomorrow, here's the layout of the quiz. Because I often have questions about the quiz. We're going to spend the beginning of class with a do first to kind of help you review a little bit, okay? Then we're going to start the quiz. It's going to be a short one because it's not like one of the district unit quizzes. It's just one I'm grading so you have more opportunities to kind of see where you're at. And so it's 6 multiple choice questions. I went ahead and made it only multiple choice. That means 3 problems and 3 problems for each of your standards for Unit 3. 3 of them are for the standard that has to do with graphs of exponentials and logarithmics. So you should be very familiar, even though we're not practicing them today, with the 2 exponential graphs. Here they are. You've got them in your notes. And the 2 logarithmic graphs. You've got them in your notes, and then you should be able to shift them around and do transformations like we did on Friday and earlier last week, okay? That's the first standard, 3 problems doing that. The other 3 problems have to do with our other standard, which is basically anything else we've learned dealing with logs and exponents, manipulating and moving things around. So that could be anything with this kind of stuff, like we did in the do first, solving logs. It could be, remember these 2 equations we learned for whenever you have those word problems that say your bank account grows at 3% each year if the starting amount was this, blah, blah, blah. Those are not bad because we're just plugging in numbers, right? But they become difficult if you don't know these equations because you will not have the equations on your quiz. They need to be in your brain, memorized. Okay? So make sure you review these for tomorrow. One of them is for a fixed interval, like a yearly rate. One of them is for a continuous rate that's growing all the time. Okay? So recap those, look at how you did on those problems on your problem set, or reach out to me with questions before you walk in here tomorrow. Yep? So let's start strong for A3. Okay, cool. Okay, next up, let's practice what we did yesterday so we feel really good for tomorrow about logs and their properties. At the very end of class, we're going to do one new thing that, like I told y'all, the new thing from today will not be on the quiz on Wednesday, but it's only going to take a quick 5-7 minutes, so we're going to do the change of base formula before we get out of here. But first, we're going to practice the properties that we did yesterday. I believe in this class, we got through expanding and practice, but we didn't really get to much condensing, which is the opposite, taking a bunch of logs and putting them back together into one. And so you'll notice that the practice today, starting down there at the bottom, starts with this one. This is one log that you're going to have to expand, right? All of these are going to be expanding, expanding, expanding. So let's come back to those when we have just time when you're practicing. Let's actually start with number 6. We're going to do this one together to kind of review what we would do if we want to do the opposite and condense it. And then y'all are going to practice some mix of these. Okay, so if expand, we said yesterday, would make things bigger. Raise your hand if you can tell me what it means to then take something and condense it. There you go.
Make it smaller.
I want to make it small. I want to take a bunch of logs, and I should be able to condense this down to where I only have 1 log. Okay, cool. Where I only have 1 log. So I've got 2 logs right here. I'm going to see if I combine these into 1 log by basically reversing all the steps and things that we did yesterday. Okay? Taking a look. I see a couple things going on. I see a 3 in front here, a 1/2 in front here. I see some subtraction right here. Any ideas of how we could change things up and use our properties to start piecing things back together? Kennedy, what would you do first?
Move the 3 back to the exponent of x.
Cool. Power property states that anytime you have a power right here, we can put it in front or we can put it on the exponent. So let's rewrite this as log base 5 of x to the third power. Move the 3 back inside as an exponent. Okay. And then Giselle, what were you gonna say?
So the 1/2 in front of the log base 5 would become an exponent?
That also becomes an exponent, right?
To the square root?
Cool. So she says two things at once. I love it.
Oh.
She says this is a 1/2, right? But do you guys agree that the 1/2, she says, could be the same thing as a square root?
Yes.
Okay, so I'm gonna write this as log base 5 of x cubed minus, oops, thank you. Should your base change?
No.
No, that is not. Okay, square root of 6 minus x. So the 1/2 is the same thing as a square root, right? Cool?
Got it.
Okay. Last up, my goal is to get 1 log. I've got 2 separate logs, so there's something else I can put together in a pretty little package. Ehong, what can I do?
You're gonna put the x cubed over the square root of squared 6 times x.
Okay, so subtraction, Diego, subtraction, we used a property yesterday that says subtraction could be combined into what operation? Subtraction went with what? The quotient, the division. So we're gonna rewrite this as, like Ehong said, 1 log base 5 with division, like Diego says, with the x cubed on the top and the square root of 6 minus x on the bottom. And now I have 1 condensed log rather than all these separate pieces, okay? Okay, so the goal of today is going to be to practice this and get really good at it. Oh, one more quick question.
When you do, like, when you get to the final answer, would it be the same to have, like, log base 5 on the top and bottom and then move it to that? Oh.
The goal is to have good, so I do not want to have log base 5 of x cubed over, this is what you're saying? I do not want 2 logs. Remember, I'm trying to get to 1 log. The property does not say that subtracting gives us 2 logs divided. It gives us 1 log with the first thing on the top, the second thing on the bottom. What this means is these are 2 logs that are being divided. So if you plug this in your calculator, I was going to say that these don't have numbers, they have like x's. You will not get the same decimal if you have that, right? So if you see some numbers later, let me know and we can like experiment, or you could plug something in for x. This will not be the same thing as if you plug in x to that. So this, no, this, yay. Okay? Okay, so what I want from y'all is, lesson first, 2 instructions. Listen! Okay, if you have this one finished up and no more questions, I want you to try condensing first because we didn't practice that as much yesterday. So I want you to start actually on example 7, 8, 9, practicing condensing. Then pause, don't start yet. When you finish 7, 8, 9, I want you to go back, we're kind of reversing. I'm going to go back to problem 1, which is expanding, and go back to practicing all those expanding. In about a minute, once you get started, I'm going to pass out some keys so that if I'm not around to check your work, you can check it with this, but I want you to start by just kind of trying it on your own. I'm going to pull those of you that weren't here yesterday, kind of this front table right here, to kind of sum up these properties that we've been talking about, and then you should be able to join the rest of them practicing, okay? Okay, go ahead, launch straight into number 7, 8, 9. Oh yeah, because you weren't, here. You done with a couple of them, Brenda? Do like 2 and then you can go. Okay? Okay, last row, who else was it? Israel? Anyone else? Okay, Leo, do you mind just scooting over one of their seats right now? Oh, you're turning them in. Okay, I don't need that.
I don't think I'm correct.
Do you want to just either here or there or something? Or you can see later. wherever you feel. Leo, just scoot over for this. There you go. Alright, nice focus. If you haven't started studying yet, you're wasting your time. Keep going. Okay, you free. If you go back also to that first page, see that box right there? I'm gonna do these right amounts we talk versus having you copy them down. We learned yesterday 3 main properties that basically showed us how we can write logs like in other forms. Kind of like you take a fraction, 1/2, and you can write 1/2 as a lot of different things like 2/4 and like 5/10. There's reasons that we want logs to look like other things, but still be the same, right? Okay. So, first thing is called the product property. That's the first one. There's going to be 3, so leave space for 3 of them. The product property states that if you have a, still looking for y'all to, I don't see a lot of focused writing, I see a lot of hanging out. We got a minute for each one. Don't waste your time. Okay. If you have a log base B of a product, 2 things that are multiplied, x times y, then you can basically break those apart into 2 separate logs that have the same base and have each of these separate pieces. So this one will have x and this one will have y. But if it's multiplication, the rule states that these 2 are going to be added together to make it still the same as this is, right? Okay. Okay. The next one is called the quotient property. Okay. The quotient property is going to state that if I have a log base B of not x times y, but this time quotient means what?
You don't times that.
Not multiply, but divide. So you're going to have x divided by y. If you have this, then you can also split these apart into 2 logs
You still need the 7.
with the base b. One of them is x and one of them is y, but you're not going to be adding them. If it's a quotient, you're going to be subtracting these 2 logs.
I don't like this.
You put the
Okay? And the third one is going to state the power property.
No, please.
Okay, the power property isn't multiplying, it isn't dividing, it's when you have a log, base b, and instead of having x times y or x divided by y, you have an x that's raised to a power p with an exponent. If that's the case, then this exponent, you all probably saw in a few of the examples. Did anyone see where we put that exponent? In the front, you can, this is equivalent to having p times log base b of x. So you can move things around that way. Okay? So one way that we found that this was something that like we could use these for is kind of like this fraction situation. If I give you a log of a big number like 75, I might want this log like in terms of other logs with smaller numbers here, so like broken up into separate pieces. So we can think of ways to rewrite logs like this. For example, down at the bottom it tells you to rewrite log 75 and turn them with logs 3 and 5. So I want only logs with 3 and 5. I don't need the 75 out of the way. So let's think, is there a way I can rewrite 75 with 3, like 3 times anything? That's another way to write 75. So 3 times, think like quarters, like 75 cents. Kind of writing 3 times 25, right? Do you agree? Same thing? Okay. Because this is being multiplied by b, the product property, I could split these apart into log what and log what. And what would I be doing with those 2 logs? If this is multiplication, I would be adding them. Good. Okay, we're closer because I got log 3, which is what I wanted. But I don't want log 25. They said log 3 and log 5. Is there a way that I can keep going and break down this 25?
I'm thinking
Yeah,
left to
what can I
right.
do with this 25?
5
5 and 5, you can either do 5 squared and use the power property, or you can do 5 times 5 and use the product property again. What do I want to do? Log 3 plus log what? You're going to do the power, 5 squared,
Since everything is
and then where can that 2 go?
what?
In the front, so log 3 plus 2 log 5. Uh-huh. I didn't square the 25, I rewrote 25 as 5 squared. Yeah, it's equivalent, right? I just wrote it in a new way because I wanted 5s rather than 25s. Okay, so that's one use. The other reason we would want these properties is to do what you kind of saw us do here, which is either take a log that looks like this and break it apart into something that looks like this, like 2 separate logs, or to take separate pieces, separate logs, and put them
You're
together.
gonna play today?
Okay, so this is not like in terms of log 3 and log 5, this is just taking your log and like breaking it up and putting it together. And that's what they're spending today's class kind of representing. And this one kind of simplifying because you're putting it together, but if you're expanding, expand is going to be what you're going to do in these first two.
That's it.
Like if you look at the bottom of our do first from today, notice that's one log,
So I just
and they want you to expand or condense. This is already condensed, so they want you to re-expand it out into a bunch of separate logs. So you're going to have like log 9, log 9, log 9, log 9, a bunch of log 9s that are going to be added together because 6, x cubed, y to the 5th, and z, all of those things, are they being multiplied or divided? Multiplied, which is why we're gonna have like log 9 of 6 plus log 9 of x cubed plus log 9 of y to the 5th plus log 9 of z. Okay, so let's walk through maybe one of these together, so that you'll have one condense and one expand, and then I'll see kind of how y'all feel with some of the practice. You got a couple of them done?
So what you do with
You did 7? Okay, let me grab the key and you can check the So y'all go back to 1, or everyone's on 1. Let's do this one together,
Any.
and then we'll move on.
Yeah, if you're like really behind on the book, you can read that or you can read your own book.
How many have you done? Okay, once,
Like if it's
Brian
something
gets
to
back.
read, I don't know, other books except in cold
Yep,
blood.
I'll pass them out. Okay, so you guys on this first one. Here's the key for y'all to check what you've done so far, okay? Once, I want you to do at least these condensing ones, and then once, you just get back. Okay, so up here, my people that were here yesterday,
You're negative.
all of these are being multiplied, right? So we're gonna split those into a bunch of separate logs that are all added together, right? So it should have the same base of 9, but each of these separate pieces. So the first piece is the 6, so that's gonna be our first log. Plus our second log base 9 is gonna have x cubed. Our third log is gonna have y to the 5th, and our fourth log is gonna have z. Okay, let's keep going.
Parentheses around
The
this.
3 and the 5 are exponents, so where can we put them?
Let's
In
say
front, so I can say log base 9 of 6 plus 3, log base 9 of x plus 5, I can move the 5 in front. Log base 9 of y plus log base 9 of z. Y'all finish all of them? Almost. Let's start moving you.
Almost isn't all
Okay.
numbers.
Last thing, I want to make sure, when I say expand, I want you to literally expand it as much as physically possible. Okay? There's nothing else I can do with this. Nothing else I can do with this because I moved the 5 in front. Nothing else I can do with this because I moved the 3 in front. But let's look over here at the 6. Kind of like our 75. Can you think of a way that we could break up this even more? 2 times 3. So Israel Lazaro, he said I could keep going with this 6. I could break up 6 into 2 times 3. Do you agree? That's still equal to 6. And then I could break that into one more time, 2 separate logs. log base 9 of 2 plus log base 9 of 3, because multiplication is addition. So I have
All these always gonna graduate.
so you know it's very expanded, like there's a lot more logs to this structure.
Racing is a faster class though.
Okay? So you use that example for all your other ones. And I'll be around to help. I'm gonna start checking in on some of my other groups coming to Zone. How you doing?
So 4-year college, right?
You okay over here? I'm gonna be doing like condensing.
So 4-year college.
Even if you guys for me, that right now I'm talking to you again, or that's me, any other one. You should have gotten, when you got this, you got both pieces.
It's not squared still, yeah, it's been distributed already,
Okay,
so
that's gonna make it a little difficult.
So
I said I had
Because I don't have your.
Okay, you can't use it, you look at it. They literally set the tape.
Yeah, they can cover it.
Wow, now he wants to talk. Oh my god.
I could get you a blank test, because you're gonna have to like a problem to read all of it right to me about. It's hard for us to know like which one you got missed if you don't have that. Because I don't know which one got missed, all I have is your student. Okay, so let me see you tomorrow if I can get a blank test. Okay, how do we do on these ones? Bad? Okay, so let's see what it says when you have.
So we're.
Yeah.
So it looks like you started, I don't expect you to get here on one step. I think you started right. You have this, you put 7 inside, plus log 3 to b, and then it looks like you put the 2 inside, right?
The first thing I did was.
Like that?
So now
Okay, the only thing with the 2, I think that's all our regular, is that technically the 2 is on both of them,
let me guess, like Stanford.
right? Because if the 2 is in front of both of these, then the 2 goes on both. So we have to square the 8 and the c. So you're gonna end up with 64 squared. Okay. Now we wanna start putting the pieces together. Okay, so if I wanna put these first 2 together, if I've got, I'm adding 2 logs, what am I gonna do with this piece and this piece? So that's where I end up with a log base 3, I got
Oh, whenever they ask me.
minus.
Yeah, you didn't tell me.
Where'd you get it?
Right? Okay, now I've got a minus,
Huh?
which means I'm gonna do with this and this.
Where did you apply?
Divide, which is where I get that 8 to the 7th power.
I think it's, I need to.
Okay, so I wrote all these notes and I'm solving it. The key that I gave you all.
And after that,
Like you were started right.
it's like there. I just have to hit submit.
Looks like where you had to check something.
The flight tech?
Yeah.
Should we write your
Yes.
Now start multiplying the things that are added, dividing by the things that are subtracted. 1 step at a time. First put those 2 together.
6. You got to upsplit it. There's like 2 like that. Because you're spending the 6. What? What am I here? Like the 5? Because you can like the 5 can be squared. 5 or like the 64 but like the 7. No wait. The 8 and the 7.
Yeah.
You should be right.
You happy?
It's gonna be like power.
Did you check those? Okay.
You can put it times 3, just for times 3.
What's the file?
Everything's from
And then how will you do this? That is
Okay, so the C, like
Plus,
order of operations.
that's
Eight times B. Like I would do all these things. I would do first time multiplying 13 times.
It's gonna be log 2.
Alright.
Oh yeah, because
Then I'm taking that 13 and I'm dividing it by.
That's what's gonna be on top.
Then I'm taking all of that
9.
Oh, well, it's not
and I'm
literally log.
multiplying it, adding times C. So like I'm basically multiplying the whole thing times C.
Yeah.
It's just gonna be
The whole thing times
No, they get to do like log means 9.
So I multiply it like this.
If I had parentheses.
Okay, now since this is multiplication, you have to separate those two.
Like and then the.
So you're gonna use like log 9, 2 plus log 9.
They would have needed to then both have.
That's times be like the whole thing.
no.
It's the exponential. Logs and multiply together. Times the
Well, I'm putting the 2 on whatever is in the log. I'm not putting the 2 in the order. So the first one, I'm putting the 2 on A.
Should be the
Yeah, so if there's not parentheses there, I'm still taking the log.
You don't give us this stuff? They just have to hit that.
Because you put the 2.
Okay, so this one you didn't get it? Okay, so here, since it's writing, I separated it by subtraction, right? And then the 7, I moved it in front.
Is that because there's no parentheses? And you're saying like I didn't think both of these things were in the log? You're arguing to me that you're saying this is log is 8 and then like C's over to the side. So what does the 2 go on?
So
It
then,
goes on
since
only
it's
the
gonna be
8.
like a nice one,
But like we're saying log of 8C, which means the 2 goes on.
yeah, since it's like in addition kind of thing, you have to put parentheses because you can do nothing with it. You don't have learned the proper
64 C squared.
property.
Whenever you have something to a power, you have to square both.
Like this.
So now that you have that on the top, that's all, yeah. Divided all by,
And then, but you know how to get this, right?
These look good.
remember you only have one element for the entire equation.
This, yeah, the squared goes on both of them. Which, but that's why it turns into 25, right? So since I'm squaring, anytime I have something squared where I'm squaring the whole thing, this is not 4x squared. It's 4 squared and x squared, so it's 16x squared.
So is it okay to put plus negative instead of just negative? Because it confuses me. Because if you put just negative, then
Which is because, so you can write plus negative, but I like writing it as minus because it builds the connection that from the beginning, another way you could have solved was writing this as h squared j to the 11th over k to the 5th, because since it's a negative exponent, couldn't I have written it on the bottom?
Yeah.
Which means when I would have solved, I would have gotten log 7 of h squared plus log 7 of j to the 11th minus log 7 of k to the 5th. Right, so like, and then move the 5 and move the 11 and move the 2. So I like writing it as a subtraction, but you can totally write it as plus and negative, because subtraction and plus and negative is the same. But don't let the subtraction confuse you, because it does mean divide, because you could have written that k to the negative 5th as division from the beginning.
Okay, so since it's like separated by this, why don't we do this?
Okay, so if this had parentheses, then you would multiply these before you did the division.
Okay.
But if you don't have parentheses, then that means you're doing a lot of steps in one, but you're doing this whole thing in order. which means first you're doing 13, which is the 7 one up there, a to the 7th, minus 11, and dividing it. Okay, so the next thing you'll do is divide, and get 13 a to the 7th over a to the 11th. The last thing you'll do is multiply, which if I multiply this whole thing, not just to the b to the 11th times c, that's like multiplying times c over 1, the c is going to end up on top. Okay, so notice like you would need parentheses here, which means you would distribute the negatives, and both these would be divided or on the bottom. Okay? Well, it cannot be true. So it looks like this, right? Decreasing for all values of x, not true. Oh, so you're saying there's 2 that aren't true. Okay, just circle both of them. That's fine. Brian, let me see what you got. Okay, so one step at a time So let's go one step at a time. When we write down next paper.
You trying to kill us with
What am I doing?
There's only 3 questions. I think you get a first one. It's the first one is
Right now they are
monopolistic. The other one is only, yeah. 3 is hard. It's fair. Number 3 is fair.
But is that
Yeah.
Okay, so rewrite this as long base 3.
There's only 3 multiple choice.
And then
Okay, that's a little better.
It's condensing, right? And write the rest of it. Minus.
No, these.
I need to put.
Alright, log of 5. And then what's the other one? Expand.
Okay, now write minus.
They learn about
Then you're gonna see that because it's minus.
I learn about 2 more
You're gonna
exams.
divide it.
I understand it. It's easy. ABC.
Okay, I just here.
Easy, but
What's this up?
I'll
I got a couple minutes to really quick change of base with y'all because it's super quick. But I need your focus so I can let you out on time. So voices off, eyes up here. Pause whichever one you're on. Hopefully that gave you some good practice with condensing and expanding. If you feel like you need more practice, you're welcome to look at my keys after you finish the practice, where there's a lot on your problem set. Okay, starting with where it says change of base. Notice that any of the examples we looked at, did the base change?
No.
No. So if you do want, for some purpose, to have a base of E, or ln, okay? All you have to do is take your log and write it as ln of this thing, don't back up, over ln of this thing. So grab your pencils. Grab your pencils. I want to make sure everyone's writing this down. For this first one, I could rewrite log base 3 of 5 as ln of what? 5 over ln of
3.
the 3. If you plug both of these in your calculator, you'll get the exact same decimal. They're equivalent. Not difficult, but just one more thing you have to remember. For this one, Melanie, what would you do for this one? ln of this thing over ln of this thing. ln of 6 over ln, Melanie, what's on the bottom? Of 1/2. Alright, next one. Edith, what would you do for this one?
Edith.
Alright, and so on and so on and so on, okay? We'll see change your base a little bit more after your quiz. You won't see it on your quiz, but that's all you do for the change your base for. Okay?
Hard.
All right, bye-bye.